Okay, looking at the inverse properties of the inverse trig functions in the other direction, okay, where you're doing sine inverse of sine, cosine inverse of cosine, tan inverse of tan, the inclination is that sine inverse of sine of an angle should be the angle as long as the angle is in the right place. Okay, so each one of these guys has a restriction for the angle. So here I'm going to ask myself, is 11 pi over 9 between negative pi over 2 and positive pi over 2? And if you're ever confused about that, take out your calculator and actually literally crunch the numbers 11 pi over 9 compared to, say, pi over 2. Why don't you take a moment and try that? Okay, so this is a little interesting because if the angle were between negative pi halves and pi halves, then the answer would be easily the angle itself. And in this case, 11 pi over 9 is not. It's actually bigger than pi. Now you could have also said 9 pi over 9 and reasoned this out. Pi over 2 is about 1.57. So what we need is an angle that has the same reference angle as 11 pi over 9, but is in a quadrant that we can use for inverse sine. And therefore you want to make sure you choose the quadrant where they produce the same trig function value. Okay, now remember I said this was 9 pi over 9. So this is a reference angle of 2 pi over 9. Okay, now let's think about this. If that's our reference angle, and if all we can do with inverse sine is choose the first quadrant measured positively, the fourth quadrant, same reference angle, measured negatively, then we would have to pick the quadrant where the trig function value was the same as that of 11 pi over 9. We know that sine is negative in quadrant 3, so we have to pick the quadrant over here where sine is also negative. So our guy would have to be negative 2 pi over 9. Now that's a lot to digest, okay? So I want you to think about that for a moment. You're picking, this is the real deal, the real stuff of trigonometry. If you have the same reference angle, and if you place that reference angle in a quadrant where your function should be positive versus negative, then we can pick these equivalences, okay? All right, so now we already know 11 pi over 9 is in quadrant 3. We know inverse cosine can only give you back answers in quadrant 1 or 2. So inverse cosine can only give you back the angle 2 pi over 9 or the angle pi minus 2 pi over 9. Okay, those are our two choices. Now, this is a quadrant 3 angle. Cosine is negative in quadrant 3. We know the reference angle, and we know that cosine is also negative in quadrant 2. So our answer would be pi minus 2 pi over 9. Now that's 9/9 minus 2/9, or 7/9. Okay, lastly, arctangent of tangent of an angle is supposed to be the angle if you are between negative pi halves and pi halves. We know that 5 pi over 3 is 300 degrees, which is in quadrant 4. And we know that its reference angle is pi over 3. We know that 5 pi over 3 should have a negative tangent ratio for quadrant 4. And we know that we can only measure in one of two directions. We can only measure for a tan inverse, quadrant 1, or quadrant 4 in this manner. We already know the answers in quadrant 4, so we have to basically remeasure this guy and call him negative pi over 3 because of the restriction. So like it or not, you have to play by the rules of the restrictions. Okay, so again, one more time, what do these angles have in common with the actual answers? 1, same reference angle, and 2, you're picking the quadrant that makes sense in the interval and that gives you the same trig function value as your actual angle.